Okay, we've done a little bit of prep work in our last lesson, and so now we're going to add and subtract unlike fractions. These are fractions that don't already have a common denominator. So there's a little bit of information in this box, but mainly I want to just go over that when we add and subtract unlike fractions, first we're going to find the least common denominator. Then we're going to write them as equivalent fractions. We're going to add or subtract the like fractions. Then we're going to write the sum or difference in simplest form. In our last lesson, we did all three of these as individual skills. So now we're going to put them together in problems. All right, let's take a look. Problem number 1. It is certainly just your choice, but I'm going to go ahead and write these fractions one under the other. It's a little bit more common to see it done this way, although as you move into algebra, into other courses, you may start seeing them written in this horizontal fashion more. All right, first thing I need to do is look at the 5 and the 10 and find the common denominator. What will go into both 5 and 10, what will 5 and 10 both go into? Now I could do my long process, but honestly, I usually look at the larger denominator and ask myself, will it work? 10 of course goes into itself, 5 goes into it also, so I'm going to use 10. All right, so I've gotten the LCD. Now I compare. 5 goes into 10 2 times, and 2 times 1 is 2. I just built an equivalent fraction. There's no change in this one, so no change in its numerator. Now perform the operation of addition with these two like fractions. I get 3/10. Final question, can I reduce or simplify? No, I'm done. So there's your answer, 3/10. All right, next problem. I've got 2/5 minus 1/8. And I want to find a common denominator. Now you may come up with the common denominator very quickly off the top of your head. And the common denominator is 40. That's the number, the smallest number that they'll both go into. If you wanted to, you could do that little process that I showed you in the last lesson. Smallest prime number is 2. It doesn't go into 5, but it goes into 8 4 times. Divide by 2 again. Bring down the 5, it goes in there 2 times. 2 again, bring down the 5, you get a 1. Finally divide by 5 to get the 1s. If you multiply 2 times 2 times 2 times 5, you will get 40. So you could do it with that LCD process, or it might come to you. 5 goes into 40 8 times, and 8 times 2 is 16. 8 goes into 40 5 times, and 5 times 1 is 5. Now this problem is subtraction, so 16 minus 5 gives me 11/40. Can I reduce or simplify that? Nope, so that's my answer. All right, next one. I have 3/16 minus 3/8. The common denominator, well, if I look at the large one, will it work? Yes. 16 is the least common multiple, which means it can be used to be the least common denominator. All right, no change, so no change. That stays 3/16. 8 goes into 16 2 times. 2 times 3 is 6. This is subtraction, so I'm going to take 3 minus 6. That gives me negative 3/16. In an arithmetic class, that would not be possible. But in this class, where you know more algebra, you can actually take the numerator 3 minus the numerator 6 to get this negative 3. So we did get a negative answer. All right, next one. I have 4b over 24 plus 7b over 6. The common denominator, well, will 24 work? Yes, it will, because both will go into it. No change, so no change. I get 4b. 6 goes into 24 4 times, and 4 times 7b is 28b. So I have got over 24. You might do this in your head, but you've got 4b plus 28b. Those are like terms, so I can add them up for 32b over 24. Can I reduce that? Do 32 and 24 have a common factor? Yes. 8 will go into the numerator 4 times. 8 will go in the denominator 3 times. And that leaves me with 4b over 3. So I had to do all my steps here. I had to find a common denominator, build the equivalent fractions, perform the addition, and reduce the answer. All right. Let's look at number 5. I have 7/10, minus 7/15. Now, this time, we don't have a common denominator, and 15 won't work. So you might brainstorm about multiples of 15, or we could just use our method. I think I'll take an opportunity to use it. 2 will go into 10 5 times. It doesn't go into 15. 2 doesn't work anymore, but 3 does. It doesn't go into 5, but it goes into 15 5 times. And then 5, 1, 1. If I multiply 2 times 3 times 5, I'll get 30. The common denominator is 30. Some of you might have just looked at it and said, yeah, 15 didn't work, but the next multiple of 15, which is 30, would work. So there's a lot of ways to figure that out. 10 goes into 33 times. 3 times 7 is 21. 15 goes into 32 times. 2 times 7 is 14. This is a subtraction problem. 21 minus 14 gives me 7/30ths, and I think it's already in simplest form. All right, let's take a look at number 6. I have x over 3 plus 14x over 15. To add two fractions, I need a common denominator. This time, 15 will work. 3 goes into 15 5 times, and 5 times x is 5x. 15, there's no change, so no change for 14x. This is addition. If I add 5x and 14x, they're like terms, so I can add them up for 19x over 15. There's no reducing because there's no common factor between the 19 and the 15, so I'm done. You always want to make sure when I wanted to add the 5x plus the 14x, I could only do that because they were like terms. Number 7. I have 5y over 3 minus 1/6. Common denominator is 6. 3 goes into 6 2 times, and 2 times 5y gives me 10y. Second fraction, there's no change, so I'll leave it. This is subtraction. Now this time, I'm going to try to take 10y and subtract a 1 from it, putting it over 6. Those are not like terms. Since they're not like terms, I'm going to have to leave it as 10y minus 1 over 6. Done. Just got a few more problems that I can practice with. I have 9 over 26 minus 3 over 13. Common denominator, look at the larger one. Will it work? Well, yeah, it will. So I'll keep the 26. 26, no change, so no change on the top. Oh, I'm so sorry. 13 goes into 26 2 times, and 2 times 3 is 6. It is subtraction. So I have 9 minus 6, which is 3, over 26. No common factor. I'm done. I think, well, we can probably go ahead and do both of these. If you don't need to watch the entire video, that's your choice. Just some more practice. All right, now in this one, what's good to practice is that 6 and 14 begin to ponder and can't really think. Oh, I'm so sorry. That wasn't 14. Would have been a different problem. All right, 6 and 42. Yes, the common denominator is 42. The problem I accidentally wrote down would have been an interesting one to do. No change in the 42, so no change in the 13y. 6 goes into 42 7 times, and 7 times 5 is 35. It is subtraction. I need to take 13y and subtract 35. Once again, those are not like terms. So I'm stuck with 13y minus 35 all over 42 done. All right, let's just look at number 10. This will be our last one. We won't work with 11 in this video. I have 1/8 minus 3/10. Now you could look at those and maybe you're thinking of the common denominator, or maybe you want to do our process. 2 will go in there 4 times and 5 times. 2 again, 2 times and 5 times. 2 again, 1, still bringing down the 5. And then finally, I'm going to use the 5, and I've got 1 and 1. That means that the common denominator is 2 times 2 times 2 times 5, which turns out to be 40. You might have figured that out without doing all that work, and that's great. But I want you to have a process if you need it. 8 goes into 45 times. 5 times 1 is 5. 10 goes into 4 times, and 4 times 3 is 12. I need to try to subtract 5 minus 12. I can do that since I know about negative numbers. I get -7 over 40. So in these answers, once in a while, you're going to get a negative fraction. And I don't think there's anything really new about number 11. So I hope that that's enough examples for you to feel comfortable adding and subtracting unlike fractions.